of the Unit 2 test review, talking about graphing piecewise functions. So the first thing that we will look at is the 1/2 x minus 4. So this is just the line y equals 1/2 x minus 4, but we're only looking for x values greater than 6. So you can either make a t-chart or you can use slopes. So I'm going to go ahead and write my x. We're going to plug in 1/2 x minus 4, starting with 6. And when we do graphs this point, it's going to be an open circle because we have just greater than. So 1/2 of 6 is 3, and 3 minus 4 is -1. So I can go to 6, -1. I'll also say that I'm going to have to count maybe by 2s. 2s hopefully will be big enough because there's some big numbers coming up later. So we'll go 2, 4, 6, -1. We will put an open circle. From there, you can use slope. So you can go up 1 over 2. Okay, up 1 over 2, up 1 over 2. Again, counting by 2s, so I need to fix that. Counting by 2s. Okay, so up 1 over 2, up 1 over 2. The other thing that you could do is, again, continue your t-chart. And I'm going to pick multiples of 2 so I don't have to deal with fractions. So 1/2 of 8 is 4, and 4 minus 4 is 0. So I get to 0.80, which we have. The next one maybe you want to plot is 10. 1/2 of 10 is 5. 5 minus 4 is 1. And I get to 0.2, 4, 6, 8, 10, 1, which we also have. And once you get a couple of points, I'm going to go ahead and connect them. So there's the first part. We have another part on the inside, and we're going to use that yellow part for x between -4 and 6. So again, I'm going to go t-chart route, picking x values, so I'll plug in -4 and 6 to -x plus 5. Well, the opposite of -4 is 4, and 4 plus 5 is 9. When we plug in 6, we get -6 plus 5, which is -1. So I have 6, -1, 2, 4, 6, -1. This time it's going to be a closed circle. And I also have the point -4, so 2, 4, 9. 2, 4, 6, 8, 9 is somewhere in between. This time, again, closed circle because it has the or equal to. And I'm going to connect those. If you wanted to use slopes, you could. It's just going to be up 1 to the left, up 1 to the left, up 1 to the left, and you could do that until you get to -4. Okay, the last piece, we're going to look at 3x plus 1. And we're going to start at -4. So that's 3x plus 1. If I plug in -4, I get -12 plus 1, which is -11. If I plug in -5, -15 plus 1, which is -14. -6 would be -18 plus 1, which is -17. Okay, again, open circle, and I'm choosing numbers that are less than -4 because it says we're using this third line for x less than -4. So I'm going to come find -2, 4. And I'm going to go to -11. So 2, 4, 6, 8, 10, 11. Open circle. And -6 would be down 2, 4, 6, 8, 10, 12, 14, 16, 17 would be somewhere right in there-ish. And then I'm going to connect them. Okay, so there's graphing the piecewise function. From there, it's asking us to find the x and the y intercepts. I'm going to start with the y-intercepts, because to find the y-intercept, you let x equal 0. And where this is kind of tricky is because you have 3 different lines. So for this first line, we only look for where x is greater than 6. Since 6 or 0 is not greater than 6, we're not going to look there. The third line you use for x values less than -4, and 0 is not less than -4, so we're not going to use that. So to find the y-intercept, we're going to use the middle equation. So I'm going to say that y equals -0 plus 5, so the y-intercept is 5. You want it to write as an ordered pair, it's the point 0, 5. And if you look at my graph, it does cross through at 2, 4, 5, so that confirms that my y-intercept is 5. Okay, so to find the x-intercepts, it's a similar process. We can look at the graph and kind of determine sometimes, but in case you can't tell exactly where they cross, I'm going to go back and I'm going to show the algebra of how to find it. So to find the x-intercepts, you let y equal 0. And unfortunately for us, we have 3 different equations. So looking at the graph, we can see that this bottom graph is not going to cross the x-axis. However, if you couldn't tell that, or you didn't have to graph it, then I'm going to start at the bottom. We have 0 equals 3x plus 1. If we subtract 1, we get -1 is equal to 3x, and we get x is equal to -1/3. So if we were to continue this line, right, the x intercept would be -1/3. However, since we're only looking at this last line for x less than or equal or less than -4, since -1/3 is not less than -4, we can throw that out. So we then repeat the middle one, 0 equals -x plus 5. If I subtract 5, then -5 equals -x, so x is equal to 5. 5 is between -4 and 6, so I get an x-intercept of 5, 0. And then lastly, if I look at this top equation, 0 is equal to 1/2 x minus 4. If I add 4, 4 is equal to 1/2 x. If I multiply by 2, 8 is equal to x. Since 8 is also greater than 6 and it matches its condition, I have a second x-intercept, which could be written also as the point 8, 0. So we talked about x and y-intercepts. And the last few graphs, some we can do with shifting, some we have to look at piecewise functions. So I'll start with number 15, y equals 1/3 absolute value of x plus 6. You are more than welcome to write this as a piecewise and graph the lines. I prefer to do this problem using transformations, and it does say describe the transformations if we can. So I'm going to start with 1/3 on the outside. Tells me stretch or compress. I know it is going to compress because 1/3 is a number between 0 and 1. It's also going to tell us the slope of these lines. We then have a plus 6 on the inside. Plus on the inside is going to move you left and right. It does the opposite, so the plus 6 is going to move this to the left 6. And lastly, we have a minus 3 on the outside, which is going to shift this absolute value down 3. So we can put all that together. So I'm going to go to the left 6, down 3. And from there, my slope is going to be 1/3. So I'm going to go up 1 to the right 3, up 1 to the right 3, up 1 to the right 3. In both directions, up 1 to the left 3, and my graph's going to run out. And then you're going to connect them and make a V. It is clearly labeled the x and y intercepts, so I should clearly see that it goes through the y-axis at -1 and the x-axis, it looks like at 3. The vertex is always at that split point. So looking at it, if you know the shifting, the vertex is the point negative 6, negative 3. Okay, next one we have y is less than negative absolute value of x minus 3. If it helps you, you can put a 1 there. Same type of thing. So this time doesn't stretch or compress because it's just a 1. However, there is a negative, so we say that this function is going to reflect. There's also a minus here on the inside, which is going to shift this absolute value to the right. So I'm going to go to the right 3. It doesn't move up or down, and the slope is negative, so we're going to go down and to the right, down and to the left. Since this time we have an inequality, we've got to decide dashed solid, and since it's not equal to, I'm going to put a dashed line. We also have to talk about shading. Less than tells me we're going to shade below, so the final phase is I'm going to take this and I'm going to shade the inequality below the absolute value. Hey, if you're not comfortable with that, another thing you could do to check the shading is to check a point. So if I plug 0, 0 into my function, I get 0 is less than negative absolute value of 0 minus 3. 0 less than negative absolute value of 3. So I'm asking, is 0 less than negative 3? So 0 is not less than negative 3. We shade away from 0, 0, which puts me below. Okay, so by looking at 19 and 20, 19 and 20 both have absolute values and x's on the outside of the function, which means that we have to set these up using a piecewise function. So again, reminder, absolute value of x plus 2 can be written as two separate pieces. We have x plus 2, and we have the opposite of x plus 2. And for those of you who still aren't comfortable yet, if we come and set x plus 2 equal to 0, we get x equals negative 2, which is my split point. So we use positive x plus 2 if x is greater than or equal to negative 2. Sorry, that's my child. And we have opposite of x plus 2 for x less than negative 2. So if we put that with my function all together, we get y equals x plus 2 plus x, which is 2x plus 2. And we use that if x is greater than or equal to negative 2. And we have negative x minus 2 plus x, which is just equal to negative 2. And we use that if x, oops, I messed up. This is less than negative 2, and we use the top one for x greater than or equal to negative 2. So we have our two pieces. We can now plot them. I'm going to start here. I'm going to go x is negative 2, y is negative 2. I'm going to put an open circle. And it says we're going to use negative 2 for all x values less than negative 2, which means we're going to shade to the left. Again, this is the line y equals negative 2, which is a horizontal line that would go through the x-axis, but again, we cut off at negative 2. The top one is the line 2x plus 2, and we use that for x greater than or equal to negative 2. If you need to make your t-chart, we have x, 2x plus 2. We're going to start at negative 2, which gives us negative 4 plus 2, which is negative 2. So we can now come negative 2, negative 2, and we plug in, refill in the circle. And then we're going to pick another x value greater than or equal to negative 2. So maybe I plug in 0. 0 plus 2 is 2, so I get 0, 2. Once I get 2 or 3 points, I can go ahead and connect them. Okay, there's no vertex because it's not just straight absolute value. We can see the x-intercept that it crosses here, and the y-intercept is 2. 20, like 18, what I wanted you to see is if they put y with the number on the same side of the equals or the inequality, to make this something we're more comfortable with, we're just going to move that -3 over. And the way we do that is to add 3. If we add 3, it becomes y. So I'm going to make this +3. So again, we have our piecewise function, absolute value of x plus 5. So that equals x plus 5 for x greater than or equal to -5. We have the opposite of x plus 5 for x values less than -5. So if we put that all together, we have y equals, we have x plus 5 minus 2x, now plus 3, which is -x plus 8, and we use that if x is greater than or equal to -5. Below we have the opposite, so -x minus 5, still minus 2x plus 3. Together, that gives me -3x minus 2. And we use that if x is less than -5. So now we can, alright, so we are going to look at the top one. So it says -x plus 8 if x is greater than or equal to -5. For those of you who need to make a t-chart, I'm going to start by plugging in -5. We're plugging in to -x plus 8. The double negative is going to make it +5, and 5 plus 8 gives me 13. And then pick another number that's greater than or equal to -5. So maybe we go 0. 0 plus 8 gives me 8. So I'm going to count by 2's because my graph doesn't have enough spaces. So I'm going to go -2, 4, 5, up to 13. 2, 4, 6, 8, 10, 12, 13, which is somewhere in the middle. If you're counting slopes, you can then continue and just go down 1 over 1, down 1 over 1. If you're using y-intercepts, we now have 0, 8, so we have 2, 4, 6, 8, and we can connect it. The bottom half is -3x minus 2. So again, if you want to make a t-chart, we have -3x minus 2. I'm going to start by plugging in -5. That gives me 15 minus 2, which is 13. And this time I'm going to pick a number less than -5, so maybe I plug in -7. That might get too big. Let's just go -6. If I plug in -6, I get 18. 18 minus 2 is 16. So again, counting my 2's, I go -2, 4, 6, 2, 4, 6, 8, 10, 12, 14. 16 is just going to be one more space off of it. Here was 5, or -5, 13. And then we can connect it. This time we do have an inequality. So notice I used solid lines because it's greater than or equal to. Last thing, shading greater than or equal to tells me I'm going to shade above. So the last phase of this, I'm going to shade everything that is above my line. I'm just going to make all of this up here. If you wanted to test it, you could always test the point 0, 0. And when you plug in 0, 0, not going to work, which means you would shade away. Okay, so that's a good little bit. That exam is getting a little fussy, so I'm going to leave it at that. Good luck studying. I will see you all on Thursday. Good luck, good luck, good luck.